All right, continuing on with our bleachers, the next thing that we would like to accomplish is to make this shell just a bit more full. Right now it's just a very thin shell, but we'd like to give it some thickness. Let me go ahead and jump back over to the whiteboard and show you what I'm talking about. At the moment, I'm going to, as a matter of fact, yeah, thank you, Steve. I'm going to switch this back to a brush. At the moment, we just have this paper-thin shell that we have revolved around. By the end of this video, I would like to have the following accomplished. And that gives it some thickness. And then we can revolve that thickness all the way around. We're not going to worry about capping the sides. We'll take care of that in the next video. I just want to accomplish getting the thickness of the shell in place all the way around. So this will be hollow in here by the end of this video. So how are we going to pull this off? Well, first of all, let's just analyze the drawing that I completed. So how far did we go back in this direction? Well, we know that that is a unit back in Z, negatively. That is another unit. We know that because of this guy right here. So we've just moved 2 units back. After moving 2 units back, we really are just duplicating, or at least it looks like we're duplicating our stairs. That's what we're going to do. But we're going to have to do a couple of fancy things. Let me show you what I'm talking about. First of all, let me erase some of this out because it's going to become a little messy, a little confusing here. 1 second. So, we start out and we've got the following. Come up, over, up, over, up, over. What Steve is going to do is transform this entire curve back. But this is going to be before we fuse all of our points together. So all of this guy is going to get transferred back. So if we were to go back 2 units, so we know that that's a unit, that's a unit. This curve would start right here, and it would be, the primitives would be exactly the same. So there's our first primitive. Our second primitive, of course, the heights would match. We would have this, okay? Of course, without the dotted lines, that's just to show you that we moved 2 units back and where the 2 units came from. So now to fix this, we've got a couple of problems. We've got a giant gap down here that needs to be filled in. And we have a gap up here that needs to be filled in. And we have a little extra bit back over here. Okay, actually, you know what? We don't want to fill this in. We're just going to go ahead and bring this straight down like such. That'll be better. So if we were to take, let me analyze this for a second. I know how I do this. So we got 1 primitive, 2 primitive, 3 primitive. What if we deleted this last primitive? Now remember, just a second ago I said this is before we fuse all of our points together. So we'll still be left with this primitive. So if we do that, we'd be left with that. And then what if we took this point right here and moved it in and up? Wouldn't that just result in this? It being in these 2 guys would be in the exact same place. So we need to do that. And then what if we just turned around and created a line that was 2 units long and then positioned that line so that it started here and ran back to there? Or either way, it doesn't matter as long as it filled in this area. That would give us exactly what we're looking for. So for those of you that are watching this video and you love your little fast forward, rewind buttons, now's a good time to use it because I'm going to recap what I just said one more time. This, I think, is very important. Just because I wanted to go in 2 different directions with this, but I think we're going to settle on this one. We start out with this. Again, I'm just doing 3 rows to make it easy to see. And then we're going to copy 1 unit, 2 units back. So we'll have the exact same guy. And then the final primitive. Again, each of these primitives still stand on their own. So if we were to turn around and use a delete stop, we could delete this guy out right here, piece of cake. So we'll delete him out. But we're still left with a point down there from the other primitive. And now if we were to, after deleting that, if we were to take another transform SOP, but tell that transform SOP that we're only going to be transforming a specific point, we could take this point right here, move it 1 unit back, 1 unit up. So if we were to do that, we would simply have this. All right, and that gives us what we're looking for there. And then finally, we simply create a line that's 2 units long, so that will be its distance, and we'll fill in on the bottom. And now if we run all of this down through a join, we can get everything all fused together. Looks beautiful. Except we're going to have to handle this with some care, as everyone will see in a few minutes. Now, this is part of the problem, but we do have another part of the problem, and that is as our rows are incremented, everything is fine, but as our rows become decremented, we run into an issue. When we get back to a single row, what our curve will end up looking like is going to be this, because of the way that we are deleting and manipulating our points. What? That's not going to work. What it needs to look like is this. That should represent our single row. Well, what we're going to do, instead of worrying about creating this with our curve, how about we just use a switch and have the switch between the curve system that we're creating and a grid. Doesn't that kind of look like a grid that's been stood up? If we do that, everything's set, and the grid just, has a size of 1 by 1, and that's what we're looking for, because everything, as you guys know, we're working with 1 by 1. All right, so how do we want to go about pulling all of this off? Well, the very first thing that we need to accomplish is duplicating our primitives back so that we've got this guy right here. To do that, what we're going to do is branch off of our copy right here. Just come over here. And the very first thing is we'll simply do a transform. So X, F, R, M. So at this point, the data that's coming into our transform node has all of our primitives properly spaced, nothing fused together. So we take that and we simply say, set the translate Z to a -2. 1 unit back, 2 units back in the z-axis. And so this gives us this guy right here. Perfect. Now we know that we need to delete the very last primitive. So we need to come in here and delete this guy right there. So what we're going to do is we're going to come down into a delete SOP. In the delete SOP, we will specify that we are deleting primitives, and we will set the start end of what we want to delete, because we can delete one through or number through number of primitives.
Yeah, because we can set to delete by a range.
Exactly. The range that we're going to specify, it's going to be a very simple expression using a local variable. It's just going to be $n as our starting and $n as our ending. So basically $n represents the number of primitives minus 1. So by saying $n, we're dealing with the last primitive.
Exactly, and in this example we have 3 primitives.
That's right.
But the primitive numbers are 0 based, so it's going to be 0.
Primitive 2, primitive 3.
But their primitive numbers are going to be 0, 1, and 2. We have 3 primitives, but $n is 3 minus 1 because it's the number of primitives minus 1. Which is going to give us 2, which is going to give us our last primitive.
Fantastic.
Cool.
And so that's going to delete that guy right there. So that is going to leave us with that.
Sweet.
Now we just need to move this point. So it's very simple. How about we just wire this into another transform. And we tell this guy that we're going to be moving points. So it knows that it's looking for a point to move. And now we need to tell the group what point or points we want to move. And here, all we would need to do is come in and say we're going to move $NPT, so our total number of points, minus 1.
And again, this comes from the fact that we're 0 based on our point numbers. So in this example here, we've got 5 points, but the point numbers go from 0 through to 4.
2, 3, 4. Okay.
And if we have $NPT, well, that's going to be 5. We have 5 points. If we subtract 1 from that, we're going to get 4. We're going to get our last guy.
Which means we're dealing with this guy right here. Which
we
is exactly what we
have to do something special
but
with
that
expression.
We have to do something special. and that is force this to evaluate with tick marks. Otherwise, it's going to say, here's the range, $NPT, so our total number of points minus 1, or it'll be read as our total number of points, so that number through 1.
Yeah, because we've all seen you can specify a range of points, and we did this with the pool when we had our bevel, that you could say 0.1 minus 4, and that would give us points 1 through 4. Well, here, this could be read $NPT through 1.
So this is saying 5 through, in this case, 5 through 1 is our range, and that's not what we want. So by putting the tick marks around this expression, it evaluates that before using the result on the parameter itself. So then we're going to end up with 4, which gives us the correct point. So we'll put that in tick marks. And then, check this out, very simple. We said that we want to move it back 1. So translate Z. Well, we know we're negatively in Z this direction, as indicated right there. So we'll just move it in translate Z, or in Z, 1. And that is this direction then. And then we need to move it up 1 in Y. So translate Y, up 1. And that gives us exactly what we're looking for here. So now we are left with the guy being moved right where he needs to be moved. Okay? So that's perfect. And that ends that particular chain. Now we need this guy down here to be filled in. Very easy. Let me just see where I want to put this, because this is all becoming a big mess. Let's go ahead and come over here and erase some of this stuff out. And everybody remembers that this was an open arc, 180 degrees. We've already done all that good stuff. So I'm going to create a line stop.
Yeah.
And I'm just trying to think where I want to put this guy at. Bear with me, guys. I'm just going to put him out over here. I'm going to be the reason I was pausing, I'm going to use all that space in just a second. So if I put a line, and I tell first of all, I need to tell the line what direction it's going to travel. So I tell it -1. So now it's moving in Z. So now it's moving backwards in Z, -1. Now I need to tell it a distance. So we'll say that the direction is Z is going to be set to a -1.
With X and Y obviously set
is
to 0.
So that we're running in the Z axis, but negatively. And the distance needs to be how much? 2 units, because that's what's going to get filled in here. But it's not going to sit it right here. We'll talk about that in a second. So we'll set our distance to 2. Again, 1 unit, 2 units. So that'll fill out the space. Now, to get it properly positioned right here so that it moves backwards in Z, we need to take into account what? Well, the line begins at the origin. That's where it starts. So here we are with our origin. Line starts right here and goes backwards 2 units in -Z. Okay? Now I need to move the whole thing. Well, how far do I move this off of Z? We already have that information right here within a radius. We use that to move this whole guy backwards as well. So if we move it back, because this guy started at 0 as well, so if we move that back by inner radius, and this guy back by inner radius, that means this starting point right here is going to start right here, and it's going to run backwards, which is exactly what we are looking for. So we'll simply set the origin. I'll just put origin, so OZ. Origin Z will just simply be a minus whatever is in inner radius. Okay, so I'll just put IR, inner radius. And that is going to give us our point starting here, running negatively 2 units in Z, which goes to right here. Fantastic. All right, so let's go ahead and take this guy, and I'm going to send him off to a place that I'm about to use on the right-hand side that's going to come in labeled A. Let's take this guy, do the same thing. The reason I'm pausing is I'm listening to the rain. It is actually storming here, Steve.
Oh, wow. Is it going to be storming again?
Listen carefully. Yeah,
it's crazy, because it stormed hard earlier today. Lightning and everything.
All right, so let's see. Who else do we want to do? How about we take the... What else do we want to do? We want to pull off of the copy, and we'll take that guy as well. Because we've got the join right here. Pull this guy off. And because we basically what we need is grabbing this right here. I just want to make sure everybody's with me. Grabbing this is this stuff. I still need this. And I had that right here after the copy. So we'll take the copy and put that over here into A. So we got 3 different things going into A. Well, what the heck is A? A is all 3 of these guys coming into a merge.
And we're going to have to be careful of the order that they come into the merge when, well, we'll see when we're in Houdini why, because it's hard to explain on the whiteboard. But basically the order
of the point numbers will end up the way that we're going to start joining the points, because we're looking at taking 2 points that are on top of each other, but their numbers need to flow in order to weld them properly.
Yeah.
Otherwise, instead of having a shape that looks like this, we could have a shape that looks like...
It might take that first step curve and join it to our line that's at the bottom, and then join him to our second step curve, and we'll go all over the place.
Yeah. There's the best representation that I can give you. So we'll go ahead and take this into a merge, and then at this point, we can feed it back over here into the join, and take a look at what we got. Everything looks great until we go down to a single row. The moment we drop down to a single row, we end up with that very funky scenario that looks like...
And that shape makes sense because we duplicate that one step, but then when we delete that last primitive, that whole step gets deleted.
Yep.
So we've got that initial step and
our line.
And our line, but nothing else.
And nothing else, because all of this is gone. Okay? So, this is where we'll bring a grid in. And again, bear with me. I'm thinking about how I want to draw this now. So I'm going to bring in a grid. And we'll go ahead and set the grid to a 1 by 1. Now, our join, so if we take our merge, actually we will leave this over here, because that gives us, everything's been all fused together
all fused
properly.
together, and we've got just a single primitive.
And that all works great until we get to one row, so we can bring in a switch. And then we can wire in our grid and our join into the switch. So basically, and let me go ahead and break this. So basically what's going on is, let me bring that down. I didn't quite want to bring it down for me. Hang on, Photoshop's acting a little wonky at the moment. So with the switch, we're wanting to get the shape that's coming out of our merge, that's coming from the merge into the join. Everything's fused together. So that's the shape we want. And that's great until we get down to the one row. So basically, we'll take a look at our rows. And if we're not at one row, then we want this shape. Okay. Otherwise, if we are at one row, we want the grid to come through. So then, with that being the case, now we can take the output of this and run. You know what? To make this a little easier to see, I'm just going to move my revolve down here.
Cool.
And erase it from right here. Now we can revolve. And bring back the brush real quick. And thank you very much, sir. And on the switch, for our switch input, we can just simply say switch based off of rows not equal to 1. So if it's not equal to 1, what are we going to get?
We are going to get accurate.
That's right. If we're going to get accurate.
Wait.
I have never heard that before.
No, I said our grid, but we're actually going to get our merge, so I don't know. I'm going crazy. Yeah, we're going to get our merge when it's not equal to 1, because when we have anything other than one row, we want that curve that we've just constructed.
Exactly. You made my head hurt with that.
I made my head hurt with that.
So that's going to be the expression that we're going to use to decide, is it going to be the grid going through? The bottom line is, the grid's going to get pumped through if we've only got one row.
And it may...
anything else other than one row, so if it's not equal to one row, that's going to be true, and there you go.
And it may be worth pointing out, although this should be obvious, but just to avoid any confusion, when we create the grid, we're going to set it so that it has a YZ plane. It's going to have a size of 1 by 1, and it's going to be positioned.
If we were to stand it up, it would be right here by this guy.
Because that's where it makes sense for it to be, because that's where it needs to be for that single row.
Wow, I feel like this was all over the place. All right, I am drawing out more of the network than I intended to. All right, so a quick breakdown. What are we doing? We drew the start of our profile curve. Then we simply cumulatively transformed it back for the number of rows that we wanted. Transformed for the inner radius, cumulatively copied it back for the number of rows that we wanted. Then we used this section right here to duplicate and correct this back portion. We then turned around and we used a line stop, which is back over here, and positioned him properly to give us that. So then we took all of these different pieces, merged those different branches of the network together, and after we merged them, we then ran them into the join to fuse all the points, and we'll see that it's very important, the order that everybody comes into the merge so that our numbers lay down there in such a way that everything gets fused properly.
Yeah.
And then from there, everything was great until we saw that a rows set to a value of 1 caused trouble. It's like, oh, brother. All right, so that's good news. So the way to fix it, though, instead of trying to worry about the curve, is we just simply brought in a grid and we said switch between this that came out of our join or the grid. And we'll simply base that off of an expression that's saying, take a look at rows. If rows is not equal to 1, then it's going to be a value of true. Otherwise, it's going to be false, and then we can control which of the two we're going to pump through, our little curve network or our grid, and then we simply revolve it. So that is what we are looking to do.
Awesome.
Anything you want to add to this, Steve?
Just really makes you appreciate how much easier it is to lay out networks in Houdini than when we're trying to draw these spaghetti networks on the whiteboard.
No kidding.
But good job, dude. Seriously.
Okay. Thanks. All right. Hopefully everybody was able to follow along. There's a lot of things to kind of keep in mind here, and the rain sounds so wonderful. All right. So with that, let's go ahead and jump over into Houdini and wrap up this part.
All right. So let's jump over into Houdini.
Okay. And hopefully come up with a network that looks just a little bit prettier than this one.
Just a little. Cool. So I'm going to jump into Houdini.
I have very organic lines.
Yeah, they're like spaghetti, dude.
Okay, they are. Leave me alone. Okay,
I'm just saying.
I know.
I'm not criticizing. I'm
getting
just
hungry now. All right, let's build something.
Yeah.
All right, come on, back up to the copy. Let's take a look at what we've got.
Got our copy.
That's right.
And we need to take this guy and we need to branch off and translate him back by 2 in Z, and that's going to give us the basis for creating the underside. So I'm going to middle click on the output of our copy, create a transform SOP, enter and enter. And let's rename this guy underside underscore xform. And I'm going to translate in Z by -2. And if I template our original, you can see that that's going to give us that thickness that we were looking for. We've got this top primitive that we need to delete, and obviously the point that we need to move up. So let's do that now. So I'm going to right click on the output of our underside transform into a delete SOP, and I'll rename this to delete end primitive. And we're going to be deleting, bring the parameters up, we're going to be deleting a primitive, and we're going to be deleting by range. And we've seen on the whiteboard that our range is going to be $n to $n, and I will select 1 of 1, although the fact of selecting 1 of 2, since we're only getting that first primitive, doesn't really affect it. But just so that things read nice and clearly, I'm going to select 1 of 1. So what we've done there, we've grabbed that last primitive as discussed on the whiteboard, because here we've got primitive 0, 1, 2, and 3. In total we have 4 primitives. $n is the total number of primitives minus 1, so $n is going to be 3. So 0, 1, 2, 3 gets deleted, so you can see primitive 3 gets deleted. So now we need to deal with this last point and moving him up to the top of our rows. And to do that, I'm going to wire into a transform SOP. So I'm going to right click on the output of our delete and create a new transform SOP. So I single left clicked on that from our history and enter to drop that into our network. And I'm going to rename this to reposition last point. So our group, we're going to be grouping points. It's very important to specify that we're grouping points, because if you just enter a number up here, Houdini doesn't know, is that a point number, is that a primitive number? Is a point number, so we need to make sure that we tell Houdini this is a point number. And that expression that we're using is backtick $npt -1 backtick. And that's going to grab 0.8, which if we start translating, we can see that's grabbed 0.8. We want to move up 1 in Y and over 1 in Z. So that's 1 in Y, 1 in Z, and that's going to move us to the top of our other curve.
Perfect.
So I'm going to grab our join and our revolve and just move these out of the way.
See, I don't have that luxury over in Photoshop.
Yeah, it's so convenient when things start getting inserted into the middle of a network. So, yeah, hopefully things will look a little bit more tidy at the end of this.
I'm sure. So a line now, let's go ahead and...
Yeah, let's create our line to finish off the bottom of our curve.
So we'll throw our line in and set its direction in Z to -1.
Yeah, and I'm going to rename this to profile bottom curve.
Sounds good.
And let me see, if I bring that curve in, template him, and shift template him, so we can see what we're working with as we build this guy. So currently our curve's going up in Y, and we want him to go -Z. So our direction is going to be 0 in X, 0 in Y, -1 in Z. We can see we need a distance of 2. And we need to offset our origin in Z so that we move over here, and we've seen this distance is our inner radius. So let's take our origin in Z minus our inner radius parameter up on the asset. So that's going to move him over. So now we've got the 3 different curves that are going to construct our steps. We can merge these together and then wire that merge into the join. And then obviously that will then feed through to our revolve. So we're going to get this step shape that's revolved. So in between our copy and our join, I want to create a merge. I'm going to right click on the input of the join to create the merge, because if I right click on the output of the copy, I'll get a merge before our transform branch as well as this branch, and I only want it on this branch. Since we've only got that branch coming into the join, if I right click on the input of the join, this will be the only branch that gets that merge inserted on. So I'm going to right click on the input to the join, and I'm going to create a merge sup, enter to accept that, enter to place that into our network. I'm going to rename this to merge profile curve. I'm going to wire in this section of the curve, the underside, and I'm going to wire in the bottom section of the curve. Let's untemplate both of those guys, bring our visibility down and look at the join. And you can see what happens when we get our order incorrect. We're taking our stairs, well actually we're taking line, joining it to these stairs, then taking those down and joining them to the other stairs, and we're getting a horrible mess. But what we can do, we can simply flip the order of these curves into our merge so that they run in a logical order. So if we make sure that we have this curve wired in first, then the line that joins them, and then our other line, they're in order. It's one into the next, so they get joined in that order in such a way that everything makes sense. Now, I'm going to push W to come into shaded mode, and you can see that even when in shaded mode, we have a hollow shape. To rectify this, we can check the wrap first to last checkbox on our join SOP, and what that's going to do is, currently we have an open shape. We start in one position, flow round, and we have 2 points up here on our corner. If we check wrap first to last, we get a single point up on our corner, and that means we have a closed shape, such that we then get a face, a primitive created as well as our edges. So that's fantastic, and if we take that and run it through the revolve, we're going to get our stadium with thickness. But as mentioned on the whiteboard, if we bring our number of rows down to 1, everything explodes. That's after the join. If we look at our merge, we get that curve that we saw on the whiteboard. So to rectify this, we can simply take the output of the merge, which goes through the join, and we can switch that out with a grid, because when we have one row, we just simply need a grid, and that will fix the problem. So I'm going to wire a switch between our join and our revolve. I'm going to create a grid, and I'll wire the grid into the switch as well. And I do want the grid to be the first input, so coming down to the switch, I'm going to click on the up arrow next to grid so that our grid wires in as the first input and our join as the second input, just so we match what we did over on the whiteboard. So I'm going to name this grid to single row grid. Oops, undo that and rename this guy without a capital R. And let's bring our visibility down to the grid, and then I'm going to bring and template in that line so we can see we're aiming to produce a square that's here. So first things first, let's lower our rows and columns just to 2 by 2 so we get a single face. And we can see that we need a YZ plane as opposed to a ZX plane. So YZ plane. Currently our grid is too large. If we give it a size of 1 by 1, he's going to have the correct dimensions, but the position is still off. In Y, a center Y of 0.5 will sit us up on the origin, which is exactly what we need. A center Z of negative 0.5 will align us with the origin, and we know that if we were to look at this part of our grid here, that's that original curve we had, and we offset that curve by negative our inner radius. So if we take this grid and also subtract negative our inner radius in Z, that will move us over here, sitting exactly where we need to be. So if we take a look at the switch and untemplate him, when we have a 0 here, we get our grid. When we have a 1, we're going to get the curve wiring through, which obviously is going to be when we have more than one row.
Right.
We do need to set up the parameter on our switch so that we do select between those when we have the rows not equal to 1. So let's grab our rows parameter. And when he's not equal to 1,
he's true.
He's
Value
true.
Of 1.
Thus, he's going to switch over to this branch of the network. Thus, he's going to be using the steps, which we know are the geometry we need when we have more than one row.
Otherwise, it'll be false,
exactly.
0.
Which is going to switch us over to our grid. Exactly. And that grid is exactly what we need when we have just a single row.
So now let's go ahead and bring up the parameters and try it out.
So when we have more than one row, we get our steps, and they all work fantastically. When we hit one row, we switch over to our grid.
Excellent.
And that's going to wire into our revolve. So, turn off the snapping that I just turned on by accident. So when we have multiple rows, that works great. When we have a single row, that grid then gets revolved around.
Fantastic. And I do believe that is everything that we set out to accomplish in this video. And with that, that's going to wrap it up. Thanks a lot.